Greetings, I am Rushiraj C. Parmar. I am a third year BTech Computer Engineering student from Charotar University of Science and Technology, Gujarat. Below, I have mentioned my DT number. The problem statement that I have chose is taxonomy classification. So let's have a clear understanding of it.
The task here is to predict the tags of a question given only the question text and its title. The dataset contains content from disparate stack exchange sites containing a mix of both technical and non-technical questions. The dataset consists of 6 million entries, which consists of title, body, and tags of the questions posted on Stack Overflow. Here, title and body are the independent attributes, whereas tag is the dependent variable. The dataset is quite messy and contains a lot of redundancies which needs to be removed using pre-processing techniques. The dataset is also highly imbalanced. Out of a total 42,000 tags, the top 15%, nearly 5,500 tags, cover almost 99.0.4% of question. As you can see here, the tag C# occurs nearly 331,000 times, Java 299,000 times. Hence, we also need to reduce the biased nature of the dataset. Due to the imbalanced nature of dataset, the mean F1 score, also known as micro F1 score, would be the most appropriate metric to evaluate our model. Micro F1 score takes into account the contribution of each tag. It calculates the value of true positive and false negative of each tag and computes the overall F1 score. Whereas macro F1 score averages the result of F1 score of every individual tag. Let's have a brief overview of our solution approach. The total size of dataset is nearly 10 GB, so it would be more appropriate to store our data on SQLite database as it is more efficient computationally and works at a rapid pace even on such large dataset. After that, the most important portion is exploratory data analysis, which consists of steps like removing duplicate values, analysis of tags, etc. After this, we need to clean and pre-process the question. After completing all of the above steps, we finally make our machine learning model and compute the micro F1 score to evaluate our model. Let's discuss the solution approach in more detail. Step 1. Exploratory data analysis, data loading and cleaning. We use pandas with SQLite to load the data. We create a train.db database to store all of our dataset. The total number of rows in our database is nearly 60 lakhs. The main part here is removing duplicates value. By executing the following query, we get a total count of duplicate questions in our database, which is nearly 18 lakh, 30% of the total questions. Let's look at the number of times each question appears in our database and add a column which keeps a count of number of times the question occurred. After that, we create a database with no duplicates. We need to remove those duplicate values, as if not removed, they will add a biased nature in our dataset. The next step is tag analysis. As you can see, out of 42,06,000 tags, there are only 42,000 unique tags. These are the top 5 tags which occur most frequently. This is the distribution graph of the top 100 tags and their occurrences. So, the main observation from these are, there are total 153 tags which are used more than 10,000 times. 14 tags are used more than 1 lakh times. And the most frequent tag is C# which is used nearly 3,30,000 times. Moving further, we need to clean and pre-process our question. Due to limitation in computational power, I am able to sample only 1 million data points. As you can see, it takes nearly 43 minutes just to sample our 1 million pre-processed questions, and we are having a total of 6 million questions. Now, finally making our machine learning model. We will be using the concepts of binary relevance for multi-level problem. As we are having 42,000 unique tags, binary relevance method will create 42,000 different models, which for me can be computationally very expensive. And so one important thing to note here is that we have an imbalanced dataset. And analyzing further, we get to know that with the help of top 15% tags, we are covering nearly 99% of the questions. Hence, we can exclude the remaining tags and only use this 5,500 tags, which will be more efficient. We split the data in 80:20 ratio. After featureizing our data, we used logistic regression with 1 versus rest classifier. But as you can see, we just get 0.37 micro F1 score. So we need to change our approach. Now, modeling with only 0.5 million data points and giving 3 times more weight to title and using 500 tags only, we are covering nearly 91% of the questions. Finally, we get 0.48 micro F1 score, which is better than the initial result, and the accuracy can be further enhanced with the use of more appropriate hardware resources.